Hello everyone, for First Updates Now, I'm Tyler Olds and you're watching Behind the Bumpers. It's a fun show where we take a deeper dive into robots and really what makes them work. And I'm here today with team number 1403 Cougar Robotics from Skillman, New Jersey. 1403 dates back to the 2004 season and has really started to shine in the last couple of years with a District Chairman's Award in 2020. In 2019, they won the first FMA Regional Chairman's Award, a District Chairman's Award, and also a district win and a finalist to cap out that year. Wow. And I'm here today with Sahana and Harrison, and we're going to be diving a bit more into this modified 2020 robot, including all the aspects of the power cells, some cool sensors they have with the robot, and we'll demo a bit more, all here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. So Hannah, we're going to be starting out with the intake of this robot and kind of following that power cell journey, so to speak, on the robot. So I want to hear more about what your intake is and then any modifications you made to that and other systems as we go through.
Yes, okay, so we have an over-the-bumper intake that is that the ball runs through the orange belting. So the ball starts on the ground, goes through the orange belting, comes into our funnel topper. Some modifications we've made since 2020, our intake used to be flimsy, so it wasn't stabled in one position, and that was causing a lot of us running over balls during competition. So to fix that in 2021, we attached some wires, creating a fixed angle for our intake, which solved our problem, and now we are smoothly intaking balls from the ground into our hopper. Yeah, so we have the belting and then some chains attached to a motor.
So, and the kind of way we're going to do this is Sahana's the mechanical side, and Harrison's going to be talking about the programming and sensors. So, Harrison, can you talk to us a little bit about any sensors that might be on your intake or what's gone into some of the wiring or anything like that on the robot?
Yeah, so we have an absolute through-bore encoder, which is at a 1-to-1 gear ratio with the intake, which lets us, so it makes it so that we can know the angle of the intake at all times. So then we use a PID controller for it to know whether it's at the top or the bottom. And so that just allows us to have like a little bit of flexibility. If we want to move the intake a little bit higher, a little bit lower, we're able to do that. But in general, the intake will just rest slightly over our bumper.
Looking as it goes into the power cells going into, it looks like you got a couple poly belts that are pulling it into your hopper. Can you tell me a little bit more about that, that hopper in particular, and maybe into your elevator? And then do both of those, do they go to the same way or do they rotate opposite ways, the poly belts that are in the hopper as well?
Okay, so after the ball comes through the intake, we have a funnel-shaped hopper so we can narrow down the path of the ball so it can go up into our upright. These belts are running in the same direction, funneling the cells inwards, and then we also have a plastic cover on top to make sure that the balls do not bounce out while we're driving. Yeah, so we have that funneling in so to go into the upright. So after the funneled intake, funnel topper, we come up into our upright that are also powered by the belting that we have. So a modification that we made from 2020 to 2021 is that we saw some jamming in 2020 to fix that. Some jamming, and also some of the belts were coming off of the rollers that we have here, some of the beveled rollers that we have. So to fix that, we added 2 rollers in the front and 3 in the back to make sure that if the belts do fall off, we have some backup protocol to make sure that the balls are still moving and we do not waste time in that aspect.
So, Harrison, why don't you run us through just some of the different functions that are on this? I'd love to hear about, from the power cells jamming from a programming side, was anything done to kind of help mitigate that as well? Because I know a lot of times in the that initial hopper area, when you're funneling, a wider area into a smaller area, there can be a lot of issues potentially with power cells getting jammed there. And I know you also mentioned the elevator as well too, that Sahana mentioned as well.
Yeah, so one of the first changes we made on the programming side is like as you asked before, we're running the hopper belts at two different speeds. So one side is running twice as fast as the other. So if two balls are jammed, like if they're jammed like this, the one of the sides will be running faster. So then it will push one of the balls forward. And then another thing we do is we have two photo switches. So we have one up here right next to our camera, and you can't really see it's behind our sponsor banner, but we have another photo intake at the bottom, a photo switch at the bottom. So that lets our driver put balls in our upright while he's driving. So the one up here ensures that no power cell is gonna like jam into the shooter while it's not running. And then the one down here tells us if a ball is lined up at the bottom. So that just lets us have a little control of putting power cells in our upright while we're driving, just so that they're not like in our hopper, so we can hold more balls.
Why don't we move up into your shooter? I'd love to see maybe a little bit closer shot of the shooter itself and hearing about what you've done with that and the hood that's attached to that as well too.
Okay, so I think personally, and I think I can speak for a good amount of people here, that our shooter is kind of what we're most proud of with this bot. So with our shooter, we have a turret mounted shooter, which allows us to position our shooter while we're driving at different positions on the field. We have we have a sprocket attached at the bottom, and then this is able to rotate. Our prototyping experience in 2020 allowed us to get the most optimum angle here and speed for our flywheels and steel momentum wheels, so that we would be able to shoot the balls at the most effectively. And then yeah, that's pretty much it. We have steel momentum wheels and flywheels here with our hood as well. Yeah, so after coming through the upright, the balls are compressed in the shooter and then shot through the turret.
So Zahana, before we go over to Harrison, do you know what your compression is on the power cells as they go through, and does that change as it's going through the hood? And then I'm going to also infer that's a fixed hood, but how many degrees of motion are you getting on the turret?
So our compression is fixed throughout the process of us shooting, and correct me if I'm wrong on this, but I think it's about an inch of compression. Yeah, and that's fixed as the balls are shot. And in terms of degree of motion, the turret is able. So we have some dead zones, but the turret is able to move. I think 100.
It's about 235 degrees.
So Harrison, how as you talk to me a little bit more about some of the programming and stuff that went into it and sensors, how far away does the robot typically shoot? What is kind of the range of it? Because with a fixed hood, obviously you're going to be more dependent on the speed of your shooter, right? And how that works. So talk to me a little bit more about that and why you decided to go that route.
All right, so our robot is able to shoot from anywhere past 8 feet up to about 25, 30 feet. And the way we're able to do that with a fixed hood is we use our limelight. Our limelight serves two purposes. It locks the turret on the power port, and then we also find how far away our robot is from the power port. So based on that, we're able to adjust our shooter speed so that it's optimized like at any distance. The shooter knows how fast it needs to go. And so actually we can also have the little functionality of the robot driving while it's shooting, because we can the drivetrain can tell the shooter how fast the robot's going, and then the shooter can adjust based on that. But so yeah, that's how we're able to shoot from all the different ranges.
So Harrison, I know that we are going to take a look at some of the software that you're going to be showcasing on this robot as well too. So let's go ahead and take a look at what you have to show for that.
All right. So one thing we did this year is our programming team. We made this last year. We made a drag and drop block programming user interface. So it's kind of like MIT Scratch, where on this column, you can see all the different commands our robot can run. And so we can actually, for example, if we want to drive the robot along the path, we can, first we set the start position of the robot. So we can select anywhere on the field we want the robot to start. So like, let's say we want the robot to start here, and we want to face towards the middle of the field. So what this lets us do is we can actually like combine different basic commands, like driving along a path. Like you can see, we can run our shooter, we can run our intake and all that. And then we can combine them and we can run the commands synchronously or sequentially. And then we can export the files to the robot so that it can automatically parse and read them. So what that looks like is if we want to make an auto to just like drive along the path, you can see the start position of the robot, and then so we're gonna start it where we start, and then we're gonna select another point. So if we want to pick up these 3 power cells, for example, we could just add some points and pick them up. And then if we want to run our intake while we're doing this, we can just add a parallel command, which will run the 2 commands in parallel. So I'll drag a command in here. So now we're going to be running our path driving code while we're running our intake. So then what's good about this is this just lets us make autos on the spot, and you can actually see like what the robot's going to be doing and how it'll look at each stage in the auto.
So do you actually do this like prior to each match essentially? So you'll meet with your alliance partners and say, hey, this is what we typically do, but we can adjust as need be?
Yeah, so we were actually able to do that at the competition.
Yeah.
So like we had the autos that we were specialized in doing, specifically picking up either these 3 power cells or these 3 power cells. But if we needed to, we could on the spot just say like, oh yeah, we can start over here and then go take this route to pick up these balls, and we can even like show them because it shows you what the auto will be doing.
How do you calibrate exactly where your robot's starting on the field? Because from how precise you are this far zoomed out on a field to actually making sure the robot's in that exact same spot, what kind of feedback do you get to make sure you're in the correct positioning for that and correct angle?
So for the correct positioning, since we're able to give set the values precisely instead of just clicking on the field, and we just found like different reference points on the field that would be useful to line us up. And then also when we were starting our robot, we always started it at like an easy to line up angle, just so like that allows us just to, because if we need to turn or something, we can just account for that inside of our path, so we don't need to start off the robot at any like precise angle.
Sure, that makes a lot of sense. That's really cool, guys. This is really neat. How long has this type of process? Is this the first year you've been doing this in the 2020 season, or have you used this for other games as well?
So yeah, this is the first year we implemented this. So in the past, we used something. It's on our website called Cougar Echo, where it like records the operator's inputs and then can replay them. But with this, you don't need to pre-record it or anything, and you can actually see precisely what it's going to do, and you can like export it and import it. But this is the first year that we were using this exact like mechanism.
Well, Sahana and Harrison, thank you so much for taking the time to show off Cougar Robotics 1403. Wow, what an incredible set of software and mechanical features you have. Can't wait to see, of course, how you do at the at-home challenges for this year, and thanks for taking the time with us to show off your robot.
Thank you for having us.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.